All right, geometry students, today we are moving into our fourth type of transformation called dilation. We should be able to dilate points and figures centered at the origin using a scale factor. So in this lesson, we will be defining dilations, determining what scale factors are, what they mean, determining a dilation rule with the origin as the center of dilation, and practicing a little bit with these concepts. Please make sure that you're following along with our guided notes, and let's get started. So a dilation is either an enlargement, meaning making an image larger, or a reduction, meaning making the image smaller. A dilation is an enlargement or reduction of a figure with respect to a fixed point called the center of dilation. Center of dilation. A dilation is an example of a non-rigid motion. You know, we've been talking about the past few lessons, rigid motions, which result in congruent figures. This time we're working with non-rigid motions because they do not preserve congruency. In other words, a dilation produces similar figures, not congruent, similar figures. This means that all corresponding angles are congruent and all corresponding sides are proportional. You'll notice on the left that triangle ABC is enlarged with the origin being the center of dilation. It's being enlarged, dilated, to create triangle A prime, B prime, C prime. The angles will always line up. Angle A and angle A prime are congruent, B and B prime, C and C prime, but the side lengths will not be the same. The side lengths are proportional to each other. They are enlarged with the same scale factor, which we'll get into in just a second. So scale factor indicates how much the figure will enlarge or reduce. The variable we use for scale factor is k. So when k, the scale factor k, is greater than 1, the dilation is an enlargement. So let's say the scale factor is 2. If the scale factor is 2, that means our figure is going to double in size. But when k is less than 1, mainly we're thinking fractions here. When k is less than 1, the dilation is a reduction. It's going to get smaller. So if your scale factor is 1/2, that means your image will be half the size of the preimage. When the dilation happens and the origin is the center of dilation, or in other words, if P with coordinate x, y is the preimage of a point, then its image after a dilation centered at the origin with scale factor k will follow this rule. We're starting with xy, and then we are multiplying the x and the y values by the scale factor. So kx, ky is your resulting point. So let's practice. I took examples 1 and 8 for us to practice with. And so we're asked to graph and label each figure and its image under a dilation with the given scale factor and assume that all dilations use the origin as the center of dilation. If dilations occur where the center of dilation is not the origin, similar rules apply, but we would have to translate the figure before enlarging or reducing it. So let's get started. For example 1, we have triangle RST with vertices R, S, and T. The scale factor is 2. In this case, our resulting image is going to be twice the size of the preimage. So I'm going to plot my original points. I've got R at negative 5, 1. I've got S is at negative 3, 4. And T is at 2, negative 1. Okay, so here is my resulting triangle. Now, if my scale factor is 2, that means I'm multiplying x and y values by 2. So r prime would be negative 5 times 2, which is negative 10, and 1 times 2, which is 2. R prime would be at negative 10, positive 2. S prime, multiply x and y by 2, I would get negative 6, positive 8. Negative 6, positive 8. And t prime, we're starting at 2, negative 1, so the image point would be 4, negative 2. 4, negative 2. And here is my resulting triangle. Things are going to overlap a little bit, but that's okay. That's meant to happen. Okay, so you'll notice the resulting triangle, if I had a ruler here, it would be doubled in size. Let's try another one. This time, with example 8, we're going to graph the image of the given trapezoid using a scale factor of k equals 1/4. In other words, our resulting image will be 1/4 of the size. So let's apply what we know. First, I want to identify what are my coordinates. So I know that f, our pre-image f, is at negative 3, 8. And I know that G is at 1, 2, 3, 4, 8. H is at 8, negative 4. And I is at 6, negative 4. Sorry, negative 6, negative 4. So we can use these pre-image points to find our image. There are two ways to do this. We could multiply all of the coordinates I just identified by the scale factor of 1/4, or divide each one by 1/4. Or I could also determine how far away each coordinate is from the center of dilation and reduce that distance by 1/4. I'm just going to use the coordinates I'm given for now. And I just realized that I made a quick error here. Point F is at negative 2, positive 8. Let me fix that really quick. Okay, so I'm going to multiply all of these coordinates by the scale factor. So f prime would be, well, negative 2 times 1/4 would be negative 1/2, or negative 0.5. And 8 times 1/4 would be 2. I'm just going to quickly go and identify all of my image points. 4, 8 would become 1, 2. H prime would become 2, negative 1. And I prime would be negative 1.5, negative 1. So I'll plot all of these points. Negative 1/2, positive 2 is f prime. G prime is 2, sorry, it's 1, 2. Here's G prime. H prime would be 2, negative 1. And I prime would be negative 1.5, negative 1. And so here is my trapezoid, 1/4 of the size of the original. For additional practice with problems like this, you can try out 2 through 7, 9, and 10. Don't feel like you have to try all of these, just enough to solidify your understanding of this concept. I've got a little bit more to practice here. So looking at number 11, we're given that A prime at -10, -8 is the image of A after a dilation centered at the origin with a scale factor of 2. And we're asked to identify what are the coordinates of A. So in this case, we're going to have to work backwards. We know A prime, and we know that it's been dilated with a scale factor of 2, meaning that A has been multiplied by 2 to get A prime. So if we're going to work backwards, that means we need to multiply the image points by the reciprocal of 2, or reverse our process. The reciprocal of 2 would be 1/2. We're going to multiply both the x and y values of A prime by 1/2 to get A. So here's A prime, and we're going to go 1/2 times -10 and 1/2 times -8. And that's going to give us A. So that means A will be at -5, -4. And if we wanted to double check our work, we could see that A at -5, -4, if we dilate this with a scale factor of 2, in other words, if we multiply x and y by 2, we're going to get -10, -8. So this would be our final answer. Here is our pre-image point. And for 16, let's identify the scale factor given the graph of the image and its pre-image. So here we have, looks like two trapezoids. We've got wxyz and w prime x prime y prime z prime. So in this case, we need to determine the scale factor just by looking at the image. Here's what I would do in this instance. I would take one set of corresponding points. So let's just take w and w prime and determine what their coordinates are. So w is located at -2, +2, whereas w prime is located at -8, +8. So if we compare the points, if we see what's going to take us from w to w prime, or -2 to -8, I can see that we're going to have to multiply both values by 4 to get the image point. So in this case, the scale factor is 4. Our pre-image is 4 times smaller than our image. In other words, we enlarge this by 4 times. For additional practice with concepts like this, try out questions 12 through 15. So that was our video. That was our concept about dilations. Thank you for watching. Make sure you try out some additional practice problems, check your answers with mine, and ask for support if you need it. Thanks again for watching. Have a great day.